Hey guys, so I'm going to go over the test from last week. Make sure you guys fill out your test correction forms before you can sign up to do a makeup test. Let's jump right in. Number one and number two, we kind of went over in class, but I just wanted to go over a little bit more in detail about this whole idea of recursive and explicit. So on the left hand side, all of those are actually recursive. If you look at it, there's not a lot going on over here. It says, the first one says f of 7, so you're starting at initial term is 7. And then what you're going to do is you're going to actually just add 3 each time. Because of that, we talked about, instead of adding 3 each time, we're actually going to be multiplying the number of times 3 is added to an initial term. So because I have adding 3 each time, this is my best choice because my initial term here is 7. So the function here could have been arithmetic, so it could have been a sub n is equal to a1 plus your common difference. In that case, that's the recursive for that one. The explicit will then be a sub n is equal to the difference times the previous term minus 1 plus the initial term. Okay, so those are explicit and recursive. And then this one right here, that multiplying by 3f, 3 times your function, that will be exponential because of the common ratio right there. And then the last one, this one, you're starting at 3, and then you're adding 7 to the previous term. So that is actually the correct choice right there. Okay. Let's move on. A city planner is monitoring the water level in the city water source. The function h of t, as shown below, can be used to determine the level of water for each week, where t is the number of weeks elapsed, and ht is the level of water in inches. Here, I'm going to pop this question real quick. Looking at the picture, I have h of 0 is 50, so we got 50 right there. And we talked about in class this being recursive. It doesn't really make a lot of sense for this to be explicit because of this h times t minus 1. This h is the height of the, and this t minus is the previous. So this is the water level of the previous week. So all you're doing each time is you're multiplying by 1.1. We'll get more into exponential growth, but really the water level is increasing by 10 each week. That one whole, that 100% is, you're going to take 100% of last week and then you're going to add that extra 10%. So 50, what you're going to do is you're going to multiply by 1.1 each time. Going to multiply by 1.1, and 50 times 1.1 is 55, and then what we're going to do is 55 times 1.1, which is 60.5, and then 60.5 times 1.1 is then going to be 66.55. Okay, so this is definitely a geometric sequence. Okay. Remember that can't really be explicit because of that h times t minus 1, the height of the previous week. Recursive, you're just telling somebody what to do each step of the way. Recursive, again, is to find the next term. Explicit is to find any term. All right, let's move on. The sequence below is arithmetic, determine the missing value. So we know that we're adding some common difference. Okay, so once we figure out that it's arithmetic, we can actually just treat it like it's a normal linear function, which would be, here is my first order pair, 635. In other words, when I input 6, I get 35. My second one, I input 1, I get 5. I'm going to go ahead and find the rate of change between the two. So 6 to 1 is minus 5. 35 to 5 is minus 30. So my slope here is, my change is negative 30 over negative 5, which would then be 6. So every step of the way, I'm increasing by 6. So 5 plus 6, my common difference is plus 6. So 11, 17, 23, 29. Okay, so that's a fast way to do something like that, because once we figure out what type of pattern is changing, you can treat it as an ordered pair to find your input and output. Okay. Next, we have a geometric sequence. So a geometric sequence is going to be In this case, f of x is equal to the first term times the common ratio to x minus 1. Alright, so we need to figure out what can we multiply to get to 24. You can do some guessing or checking here, but I have the first term. The first term is 3, so I can actually put 3 in there. And instead of f of x, I can put in 24. And when I multiply by 3, what can I multiply 3 to get 24? I multiply once, twice, 3 times by the common ratio. So that would be the same thing as multiplying the ratio 3 times. So that would be r to the 3rd power. So here, I'm going to solve for it algebraically. 24 is equal to 3 times r to the 3rd. Okay. So then what I would do is I would just go 24 divided by 3 is equal to r cubed. R to the 3rd power is 8. Cube root each side. R is 2. Okay, so I'm just going to multiply by 2 each time. So 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. So that would definitely work. Okay. Next, I have consider this function in explicit form. I did go over in class. This is geometric and explicit. There is no f of n is equal to a1 times r n minus 1. Whenever I have n minus 1, I have term 1. Since I don't have n minus 1, I just have n, this must be when f of 0 is equal to 5. That's like at the beginning. That's before day 1 has happened. So the only one that matches that would be that one. Literally the one that matches would be that one, because I am multiplying by my function of the previous term by 6 each time. Okay, so 6 the function times the previous term. I also gave you credit if you gave me something like a, because f of 1 is equal to 30. Technically that would work as well, it just doesn't match its recursive form. Recursive again is basically saying, hey, at the beginning you have 5 and you multiply it by 6 each time. A doesn't work because you say, hey, on day 1 you have 30 and then you multiply it by 6 each time. So one is more of the y-intercept, the other one is more of day 1. Okay. Number 6, I have, this is the recursive. Again, looking at this, you're going term 1 and you're going to add 3 to the previous term each time. So the only choice with that would be B. Here is my term 1, 10, and then I'm adding 3 to the previous time, or previous term each time. I got D, as some students would say, but D wouldn't work because that 3, that would be 3, and then you would add 10 each time, so it would be something like that. So this one doesn't work. The only one would be B. Number 7, considering the sequence for the first 5 terms, write an explicit that can be used to define and continue the sequence. So first, I need to figure out if this is arithmetic or geometric. Okay, so looks something like that. 3 plus 1.5 would be 4.5. 4.5 plus 1.5 would be 6, but I get 6.75. So this is actually not arithmetic. This would be geometric. So term 1 is equal to 3. Term 2 is equal to 4.5. Geometric, I got to multiply to go term 1 to term 2. So to work backwards, I would divide. So I would divide 4.5 by 3, and I would get a ratio of 1.5. I'm not going to stop there. I'm going to check it again. I'm going to go 6.75 divided by 4.5, and I should get 1.5, which I do. So there's my common ratio. My common ratio is 1.5. So explicit would be, going down here, let's go f of x is equal to 3 times 1.5 x minus 1. This one would work because you have the first term. Now if you don't want to use the first term, you want to go back to term 0, it would be f of x is equal to 2 times 1.5x. That would work too, because we're going back to term 0. We don't need that x minus 1. We'll get more into translating that function later with the x minus 1. Okay. All right, the last one here. Don't forget number 9 already has its own video. This one, definitely arithmetic. I'm adding each time, and I just need to write a recursive. So you can go something as simple as a sub n is equal to the previous term plus 8. You can even go as f of x is equal to the function of the previous term plus 8. Something like that. Either one would work. Okay, again, recursive, pretty much just telling you what the next term is. Explicit, though, is the one that's input and output, let you figure out any term in sequence. All right, guys, I hope that helps. Make sure you guys do this in your test correction. Thanks.